Hi, we are the LinkinBot team from Portugal, composed by Beatriz Oliveira, Samuel Silva, Miguel Correia, Vasco Magolo, and Roberto Valente. Our performance aims to recreate the room of toys we see on the emblematic Disney movie Toy Story. So they have on stage 4 button roll 1A, who will impersonate the herd keeper called Betty, her one ship, 2 puzzle toy boxes we often see on kids' rooms. We also have a Lego robot and a smart car, but as we all know, in the film Toy Story, there is a villain named Sid who destroyed toys and then used the remaining pieces to build new terrifying toys. In the movie, he built a spider with the head of a doll, so we recreated her as our villain. This is our first feature, the storytelling ability of the robots. Button Roll 1A can be connected to a vast array of Arduino-compatible shields, such as wireless communication, GPS, GPRS, and sensors to perform various tasks. We choose to use infrared emitters in the obstacle detection circuit to make the ships follow the herd keeper. The working base is a TRS-T500 reflective sensor, which is an infrared sensor, emitter, and receiver, which functions from the reflection of signals. Something we also often see in kids' rooms is Legos, so we also use the LEGO Education Spike Prime kit to build a PID balancer robot. We based the start of the robot on a project that we found online, but all the rest of the robot was built by us. In this robot we included LEGO Spike distance sensor. Our second feature is the smart car, which includes a Husky lens. This is an artificial intelligent vision sensor. It comes with multiple functions such as face recognition, object tracking, object recognition, line tracking, color recognition, and tag recognition. The machine learning technology enables Husky lens to learn custom desired actions, allowing us to teach him how to recognize Miguel's face, a red ball, and the environment. Our third feature is the LEDs. To better convey our messages, we use the installation of LEDs on the eyes of the doll's head, in the toy puzzle boxes, on the herd keeper, and in the 2 ships. With the emission of color and light, we can make feel in the public the emotions we want to pass through. The circuits developed are related to the use of LEDs, RGB digital LED tape, and will be presented next. For the herd keeper, we proceeded to the installation of the LEDs divided into 3 blocks connected in series. In our particular case, we have chosen using an external power supply with 10,000 mA because this has in its structure 31 legs and the engine battery does not would be sufficient to feed everything. The puzzle toy boxes circuit is similar to the herd keeper but only with 5 individual legs. Now let's talk about the spider. In order to organize the 12 servos, we created a simplified protoboard that connects all the servos and provides them the energy. Again, we had some issues concerning the power supply. After some tries and some math, we opted for a 5000 mAh battery to feed the servos, and a 9 voltage battery to power the Arduino. Even though it only supports 5 volts, it has a built-in voltage regulator. Our fourth feature is the spider. The spiders were printed in 2 3D printers XY Aware for Pro and Crealite. We used 4 golden and black ABS and PLA reels until we had all the desired parts. We ended up only using the golden ones. The project on which we based used Nano Arduino, but we used a Mega Arduino because the Arduino Uno can only control 12 servos, and with the addition of the 360 servo Modelcraft micro server MC1811, this was no longer enough, so we had to do this upgrade. We used the servo standard XG510 6KG, so we had major changes in the shape and geometry of the spider. For the herd keeper arm, to gain mobility, we had a 12XCG90 servo. Bot and Roll 1 was programmed in the C language, and the Lego robot was programmed in Python. The language we use in the smart car is based in C++. The biggest difficulties were in the process of building the spider. The 3D printer did not give us the pieces exactly as we designed them, so after printing we had to sand all the pieces manually to refract the friction and add grease. After they were assembled, we had to calibrate the servos. We had to come up with a 0 point where the rotation starts so that everyone is in line. We ran the program with all the pause at 90 degrees. This was a very critical step. In the robot button roll 1A, and given that we use engines without encoders, the friction was the biggest challenge, being the most inconstant variable. And the use of external batteries on all robots led to mass center changes, which also led to changes in programming. With the Lego robot, we did a gyroscope robot. Our knowledge in mathematics is not enough to calculate the PID, so we had to understand the concept of 3 variables and go for trial and error, which proved to be quite difficult and time-consuming. With Husky lens, the camera recognition capability is limited, so sometimes he would confuse colors and dimensions, so it was a long process understanding the best way to teach her. Thank you for watching!